In this video, we're going to begin the Trig chapter in this book. So let's quickly review the trig functions that you need to know on this exam, I believe. Remember, there's sine, there's cosine, and there's tangent. I don't think you need to know any more. Sine, if you remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. There's the acronym SOHCAHTOA, if that helps you remember it. And remember, these relationships only work for right triangles. Okay? That's a key point. You might get fooled to use these in a non-right triangle, but it doesn't work. Okay? And I think this first problem already looks like it's trying to fool you. Let's see. Let's begin now the exercises. Triangle below, AB equals BC, which equals 10. AC is equal to 12. What is the value of cosine theta? So as I said, these only work when it's a right triangle. Is this a right triangle? We don't know. It's probably not, actually. Just because these two sides are congruent doesn't mean that this is a right angle here and this is a 45 degree and this is also 45 degree. Not necessarily the case, okay? So we can't assume that. And actually, if you pretend there's a right angle there, you do the Pythagorean theorem, 10 squared plus 10 squared, is that equal to 12 squared? For sure, that's not. So again, I just proved that this is not a right triangle. So you have to be very careful to not assume that. So cosine theta would not be 10 over 12. No. Okay? By the way, cosine theta, you can already eliminate d. It can't be bigger than 1. Okay? Now, actually, maybe let me explain. Why can't it be bigger than 1? Well, in a right triangle, isn't the hypotenuse the biggest side? So something smaller, the adjacent is smaller, so it cannot be bigger than 1. If they're equal for some reason, then it's maximum 1. But hypotenuse is the longest side of the triangle. Okay? So the math ain't mathin' for this. But anyway, so how can we solve this? Well, what if we draw something like this? We can do this. We're going to draw the height of the triangle. This height, we'll call it the height. And this will bisect this over here. So this would be 6, and this would be 6 over here. Okay? Now we can find this length over here by Pythagorean theorem, right? But do we need that? Cosine theta, now, this is a right triangle, right, is adjacent over hypotenuse, so 6 over 10, or it's 0.6. So I didn't need to find that side, but maybe I do for some other problem. Like this one, what is sine theta? Sine theta is opposite over hypotenuse, right? So what is this side over here? Now let's use Pythagorean theorem. So that side would be hypotenuse squared minus the other side squared, which is 100 minus 36, right? Which is square root of 64, which is 8. Okay, so this length over here is actually 8. Now sine would be 8 over 10, or 0.8 then. Okay? What is the value of tangent theta? Well, tangent is opposite over adjacent. So it's 8 over 6, which is 4/3. So tangent can be bigger than 1. Clearly this is in this case, right? Okay? So that's how we solved that one. Again, key point here was we could not assume this angle B over there was a right angle, and it actually did not work out. Okay, so in the figures above, y is less than x less than 90, and cosine x is equal to sine y. If x is this, y is that, what is the value of a? One is cosine x equal to sine y. There's actually multiple answers, but I'm trying to hint at this should look familiar. Okay? If cosine x is equal to sine y, that means x and y are complementary. So x plus y, if they're complementary, they equal 90 degrees. Okay? We can even look back at this triangle. What is, let's call this x, and this angle up there y. What is sine of, or cosine of x? To keep it the same, if this is x, what's cosine of x? Is 6 over 10. If that's y, what's sine of y? It's 6 over 10 as well. So these two angles are complementary. X plus y equals 90. Okay, we probably need that. So if x is this, y is that, what's the value of a? Let's plug in. 3a minus 14 plus 50 minus a is 90. Okay, so we have 2a over here. Okay, this would be 40 plus 14, that is 54. Right? So a is, what is that, 27? If I did it in my head correctly? Answer is D. Okay. Given the right triangle of this guy, which the following is equal to A over C. A over C. Okay, so it could be multiple, so let's look. Sine of A, this is the right triangle, so we're good. Sine of A is A divided by C, opposite over hypotenuse. That's good, check. Cosine of B, well, we can use that property up here if we want, but let's just do it again. Cosine of B is adjacent over hypotenuse, so A over C, good. Tangent, well, tangent won't include the hypotenuse C, so we can already eliminate that, but let's also check. Tangent A is A over B, that's clearly not A over C, right? So it should be 1 and 2 only. Okay, this was kind of short. Let me see if I can... there's 4 problems here. Let's move on. Radian measure of an angle, okay? So to convert between radians and degrees, in 180 degrees, there's pi radians. Or a full revolution, in 360 degrees, there's 2 pi radians, okay? So that's how you convert. If that's what the section's about, let's see. In the xy plane above, O is the center of the circle, and this guy, POQ, measures k pi radians. The angle, what is the value of k? So this is k pi. Okay? If that's k pi, this point, O is center, this point is 1, 1. Well, I believe then, since we can even draw a triangle if that helps you out. I believe it should be b pi over 4 because it's the point 1, 1. This is like the unit circle. Okay, so let's even draw it out, okay? If you're not familiar with the unit circle. You should know it for this exam, I believe, but let's see. So this is some angle k pi over here. Okay, the length of the x is 1. So imagine there's a triangle here, okay? That's what I brought out over here. The length of the y is 1, okay? This is isosceles right triangle. So what does k pi have to be? Since these two sides are congruent and this is a right angle here, the sum of these two have to be 90 degrees, the complementary, okay? And since these two sides are congruent, the angles are congruent as well. So it's 90 divided by 2, which is 45. So k pi should be 45 degrees. What angle in radians gives us 45 degrees? It should be pi over 4. Okay, so k is a fourth, as I was saying. Okay, so this is a slow way to do it clearly, but if you know the unit circle and you see the point 1, 1, you can immediately get pi over 4, 1/4, because the angle is pi over 4. Which the following is equal to cosine of pi over 8. Okay, so where is pi over 8? Somewhere here, right? The angle pi over 8. Cosine is related to the x in the unit circle. So I guess this unit's about the unit circle. So we want the same x value, so it should be down here. Because over here in these two quadrants, it would be a negative value of x. So we can already eliminate that. So this 7 pi over 8 is in this quadrant because it's pi over 8 short of pi, which is 180 degrees. So we can eliminate that. 3 pi over 8 Well, this is a little short of pi over 2, right? 4 pi over 8 is pi over 2. Pi over 2 is 90 degrees. Okay, so it's a little short. So clearly that's not right. Okay. 7 pi over 8 is, oh, sorry, that's sine. So we're each interested in cosine. Okay, let's not cross that out yet. Cosine of 3 pi over 8, that's what I was trying to say. We can cross that out as well. Okay, but what about sine? We can use that identity, can't we not? That that we used in the 2 or 3 problems ago. That cosine of x is equal to sine of 90 minus x. This is essentially the identity that we're using, the complementary angle, that y in that other problem, right? Okay, so in radians though, 90 degrees, as I think I said earlier, is pi over 2. So subtract pi over 8. So we want sine of this guy, okay, which is sine of, that'll be 3 pi over 8, right? So it should be actually choice C. Okay? Hopefully that made sense. In the xy plane above, O is the center of the circle. Measure of AOD is pi over 3. At the radius of the circle, O is 6. This guy is 6. Okay? And this guy was, we said, pi over 3, which is in degrees. How much? You should know this. You should be able to convert this one quickly. It is 60 degrees. Okay? What's the length of AD? Well, can't we use special triangles? So this is length 6, because they tell us the radius is 6, right? And this angle AOD is pi over 3, or it's 60 degrees. So we can use, there's the right angle here, we can use the special 30, 60, 90 triangle. Okay? So if this is 6, then this is 6 over 2, which is 3, and this is 3 root 3 by the special triangle. So it should be answer D. Okay? In the figure above, what is the value of cosine of AOD? Okay. Cosine of AOD. So this is the angle in question. Let me mark it as theta. Okay. What's the length of OD? That is the x coordinate, which is 3. DA, that's the y coordinate, which is 4. Okay. This is a 3, 4, 5 triangle. Hopefully you remember the special triangle. Okay, so cosine of AOD is adjacent over hypotenuse. Answer is A. Okay. All right, I'm going to call it a part here. So to recap, this is just to review your right triangle trig a little bit. And a common theme, it seems like, is, where is it? This guy over here, where y is the complementary angle to x, which I wrote over here. We needed it over here. Cosine x is sine of 90 minus x, or you could write it as sine of x is cosine of 90 minus x, same thing. Okay? All right, so hopefully this was helpful and good practice if you needed it. Please like and subscribe if this has helped you in any way as usual to show your support to the channel.